Welcome back, guys, to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on trees. So let us see our today's question. Our today's question is based on binary search trees. Binary search trees has a special property that their left subtree contains the value which are strictly smaller than them, and their right subtree contains value which are strictly greater than them. This is the property of a binary search tree. So today the question that we are going to see is based on binary search trees only. So let us see our today's question. Our today's question says we are given the root of a binary search tree and an integer k, and we need to return the kth smallest value of all the values of the nodes in the tree. In this question, we are given a root of the binary search tree and we are also given an integer k. We need to return the kth smallest value of all the values that are present in the nodes of a tree. So let us understand this question with the help of an example first of all. In example number 1, the tree which was given to us contains node values as 3, 1, 2, and 4. These are the four values which our binary search tree contains. And the value of k which is provided to us is the 1. So we need to return the first smallest value. In the question it is clearly mentioned kth smallest value. So the first smallest value. So these values can be sorted as 1, 2, 3, 4. So the first smallest value is 1. So what we need to return? We need to return 1. Similarly, in the example number 2, we are given the tree with values as 5, 3, 2, 1, 4, and 6. And the value of k given to us is 3. So we need to return the third smallest value in our binary search tree. So the sorted can be 1, 2, 3, 4, 5, 6. So the third smallest value is 3. So we need to return 3 in this particular example. So I hope the question is very much clear to you all. We are given a binary search tree and we need to return the kth smallest value among all of its nodes. So what is going to be the approach of this particular question? What we are going to do, we know one special property of binary search tree is that if we do the in-order traversal of a binary search tree, then we get the sorted array. I repeat, if we do the in-order traversal of a binary search tree, then we get a sorted array. And if we have a sorted array with us, we can easily find the kth value of that array, which is our answer. I hope you are getting my point. The in-order traversal of a binary search tree gives us a sorted array. And in that sorted array, we need to return kth smallest value. So if the kth element in that sorted array, we can return easily. So this is the approach which we are going to follow. So in example number 1, if we do its in-order traversal, its in-order traversal is going to be 1, 2, 3, and 4. So the first smallest element is 1, so we can directly return 1. In this way, we are going to solve this question. So now let us understand this question with the help of code. See what we did. We have made one separate function for in-order traversal, and this was the function which is given to us kth smallest. So we have made one variable answ in which we are going to store our answer. Then we have called a function in-order. Here we have defined one global variable c whose initial value is 1. C will help us to take us the counter to return the kth value. So what we are going to do is we are going to perform the in-order traversal. If root double equals to null, then we are going to return. Otherwise, we are going to call roots left. In this way, after roots left, we will check if c double equals to k. C double equals to k means we need to return this particular element. This element is our answer. So if this condition fulfills, then we are going to store it in answ. Answ equals to roots 12. If these conditions don't fulfill, what we are going to do, we are going to increment the value of c. The c value will always be incremented so that the order is maintained. Then we will call roots right. And once this function gets completed, in answ, we will have the value of the kth smallest element. So after this function call is over, we will return answ. So I hope the question is clear to you all. We will see the dry run of this question with the help of example. See what will happen. We are performing in-order traversal. Initially, we have taken the value of c as 1. It will go to 3. Is 3 double equals to null? No, it is not equal to null. What will happen? Roots left will be called up. Now 1 is called. Is 1 double equals to null? No, 1 is also not equal to null. Again, root left will be called upon. Now 1 left is null. So when it will be called, the condition if root double equals to null will be fulfilled and it will get returned. When it will get returned, then it will check the condition. If C double equals to K, the value of C is 1. We have defined it in the global variable. K, which is given to us, is in the question, this is also 1. Yes, C double equals to K. It means 1 is our answer. So we will store it in A and SW. I hope example number 1, dry run, is clear. We will look at example 2 as well. What will happen in this question is, in this example is, it will go to 5. Is 5 double equals to null? 5 is not equals to null. Its left will be called. Is 3 double equals to null? 3 is also not equal to null. Its left will be called. 2 equals to null? It is also not equal to null. Again left. 1 equals to null? It is also not equal to null. Again left. Now it is null. So if it is null, then it will get returned. That is our base condition of our function. So it will get returned. Now question will check. If C double equals to K, C value is 1, K value is 3. Condition don't fulfills. So what we are going to do, we are not going to store anything in ANSW. We are just going to increment the value of C plus plus. So now C value becomes 2. What will happen? Roots right will be called. It is equals to null. It will also get returned. Now 2. If C double equals to K, C value is now 2 and K value is 3. C is not equal to K, nothing will happen. Only the value of C will get incremented. Now C becomes 3 and it will proceed to next line. Next line says roots right will be called. Right is again null, so it will again return. Now the 3 will come. If C double equals to 3, yes, now C is also 3 and K is also 3. Condition will fulfill. Now it means 3 is our answer. We are going to store it in ANSW and again increment the value of C. So now in ANSW, we have our answer stored. And once this function get completed, we are going to return ANSW. I hope the question is clear. If the question is clear, don't forget to subscribe to our channel and share it with your friends. Thank you, everyone.